Okay, well, welcome everybody. This is week 6. We are going to move on to chapter 5 of the book, which is all about sequencing. So far we've been making SynthDefs and playing individual synths, and any sort of sequencing is basically on us to either build that into the SynthDef somehow, or just sit there and manually evaluate code. But sequencing is very important, and SuperCollider has no shortage of interesting and valuable classes to help us organize sounds in time. So what I want to cover today is basically just sections 5.1 and 5.2 of the sequencing chapter. So we'll just kind of cover some of the basics and focus our attention on two classes in particular, Routine and TempoClock. So these will be the objects of our attention. There's a lot more than just Routine and TempoClock, but these are kind of foundational classes that are really, just generally very useful and kind of multi-purpose. And I've just built ourselves just a very basic triangle wave SynthDef. Nothing really interesting or exciting going on here. We just need some sound to work with. Okay. So I guess the main question we start with is how do we actually sequence sound? Now, if we try to use what we currently know, we can maybe build a function, and we'll go and do we'll play one of these at middle C, and then we'll just make a nice little major chord. So we've defined a function, and if we evaluate this function, we might want these synths to happen one after the other with noticeable difference between them, but we just get what is essentially a chord. I mean, they are happening sequentially. This is how programming languages work. It says, okay, I'm going to evaluate this function, boom, 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 right? And off they go. And so to our ears, they sound simultaneous. Like they might be separated by a sample or a control block or something, but it's not enough for us to notice. So one of the simplest and most straightforward ways to space these sound events out in time is to wait between them. And now we can no longer just evaluate this function as is. The first statement is fine, it has no problem with that, but then as we're evaluating function f, we encounter one.wait, and the interpreter says yield was called outside of a routine. Sorry, it's years of typing my name. It's very difficult to, and the Y is right next to the F on my keyboard. So yeah, so this yield and wait are basically synonymous. I guess they sort of mean different things, and maybe there are a few situations where one can be used and the other can't. But for the most part, they're interchangeable. So what do we do here? What we do is we create a routine, and we provide, for that routine. The routine basically just needs one thing, a function. And we've already created this function, right, called f. So now we have a routine called r, which is built from function f. And so now we can say r.play. All right, pretty simple, pretty straightforward. It does raise quite a lot of questions, which I'll try to cover kind of systematically here. You should probably be able to hear that the receiver of the wait message, the number 1, is being interpreted as a duration in seconds. So we can say 0.5, 0.5, 0.5. Right. Then we get half seconds. You might be asking, why are we waiting at the very end? In this particular case, we really don't need to. If this is a one-shot routine, a one-shot sequence, then once we reach the end, we don't need to wait anymore. We're done, right? So, but you may find yourself doing, iteration, and you might say, I want to do this 3 times. And actually, let's just bundle this right into there. And or maybe like this. Right? And so in this case, the weight at the end really does matter, because if we comment it out, and I guess let's slow it down just a little bit. So what happens here is dun, dun, and then we get this, and immediately after interpreting this line, we go back to this line for the second do and the third do. So the waits are important, and they're harmless if you're at the end. There's no problem with waiting a little at the end. So there's two things. So many things here to talk about. I'm try to do this without devolving into chaos here. Here's a fun shortcut. We can say routine.new. We don't have to do .new. This is fine. But the routine class has a single character lowercase shortcut, R. And perhaps we should maybe do something like this just to distinguish. So instead of capital R routine and then the function in parentheses, we can just do a lowercase r. And that's fine too. So I use this lowercase r I'm using this in the answers to homework 5, which will be assigned today. So it's good to be aware of it. It's good to get friendly with it. I think it's pretty handy to have this for routines, especially if you're going to be using routines a lot. So if we try to play this routine again, you'll notice it doesn't work. It's like, what's going on here? A routine is essentially a type of function which is state aware. So it has a beginning. It may have an end. Sometimes they go on forever. Sometimes they have a finite lifespan. But these routines can be paused and resumed. And if it's a routine with this kind of structure where it does something 3 times and that's it, then in a sense the routine is still in an active state of playing. Not really, I suppose, but it remembers where it left off. And so we're telling it to play, and it says, I'm actually at the end. I've got nothing else to do. So we can reset a routine, and then it can be played again. So that you can think of this as basically rewinding the routine to the beginning. And because of this need to reset a routine if it's finite and it's at the end and you want to reuse it, I think it makes a lot of sense to separate out the process of constructing objects that define a sequence and objects that perform the sequence. And in section 5.1, I make this distinction and I compare it to the score for a piece of music and a performance of the piece of music, where here we're basically just defining the score, where we say this is what's going to happen, but it's not until we actually create a routine and play it that we begin a performance. And the advantage of this is that you can spawn any number of routines from this function. You don't need to remake this function again and again and again. You can just say, we could put the play message here, right? And let's put this down here. So we make our function once, we're good to go, and then we can just do this. And we can do it again. Because every time we run this line, we're saying play a new routine, and we're overwriting the previous one with the same environment variable, and this is fine. So what I used to do is kind of do these two things in one go. So I mean, I guess this is fine too. You can just run this as many times as you like, because again, we are just creating a routine anew. But if you, there's a way to do this where, if you do this sort of thing that we were doing a moment ago, where you create the routine and then play it, then we just have this singular routine object, which we then have to, reset or create anew or something, right? So I just keep this in mind, and this will come into play again as we talk about the pattern library in a future lecture, where what I don't recommend is sort of making a pattern and playing it in the same expression, but instead define the pattern and then define a separate object which plays the pattern you just created. And the same thing kind of applies for ugen functions, where you might want to define a ugen function and then in a separate object create the object returned by playing that function, right? Ugen function in Synth, We have a, a pattern and a stream, and here we have a function and a routine. So just good stuff to keep in mind here. Okay, if you want to just do this kind of forever, this is a little loud for my taste. I'm going to turn this down. And we want to do this maybe 5 times or 8 times or forever. How do we do it forever? We can say inf.do. And so now we have this routine. And I'm going to go back to my previous version here, where we make our function. Just good to separate out the definition of the function, and then here we can say this routine is going to be playing of the function, right? So this will just go forever. We can stop it whenever we like, and resume. We had MIDI note 60, so if we resume now, we should start with 64. I think it's supposed to be pause. Let me just. Oh, now I've done it. What am I? So if we play this, right, and stop. All right, I'll have to get back to you on this. I'm overlooking something obvious here. Either that, or I'm mistaking routine for some other class. So apologies, and I'll just kind of get back on track here. So I'll put a comment in the video description once I figure this out. Okay. So okay, we can when you are creating routine that has no end, it is of the utmost importance that you do not forget to wait. I won't run this. I mean, this is just the function, but I won't play this. If you try to create a routine from this function and play it, you will probably hear a very loud noise followed by silence and your computer locking up. Because it's just trying to create an infinite number of synths as fast as it possibly can. And there's not really like Sonic Pi, for example, has many more safety nets built into it, where it will say, can't do this because you didn't wait at any point in the routine. But SuperCollider will not protect you from your from your mistakes. So that's I've done it. You will all do it at some point. It happens, but it's not the end of the world. Okay, as an alternative to inf.do, you can also just say loop and then curly braces. Okay, so there's a lot of ways to make more complex sequences here. I mean, you can obviously toss some randomness into the mix. You can, like if we wanted this third note to be either 67 or 69 or something, probably the quickest way to do that is just something like this. Right. Yeah. So okay, I'm having a recollection here. I'm pretty sure when you stop a routine, that's a hard stop and it can't be resumed. I'm having a memory of this, but I feel like routine can do this, but maybe not. I don't mean to get stuck on this, but it's okay. Not to worry. Okay, so let's move on. And okay. So here's the next thing I wanted to talk about. This real-time approach to using routines is common. This is whenever you want to do something with some sort of rhythmic timing. You create a routine, you put your wait times in there. The receivers of the wait message are interpreted as the duration to wait. And if we just play a routine with just .play, then these values are interpreted as seconds. And that is only because there is an instance of TempoClock that is created automatically as one of many things that happens behind the scenes when we launch the language. And that TempoClock is running at a tempo of 60 beats per minute. And this is convenient because at 60 beats per minute, 1 second is 1 beat, and we don't have to do any sort of wacky math to do. So if you're working at 60 beats per minute, great. You don't have to make a tempo clock for yourself. But if you are working at a different tempo, you will almost certainly want to create a tempo clock running at that tempo, because otherwise you have to do weird mathematical mental gymnastics with these numbers to get them to represent, you know, an eighth note at 124 beats per minute. Nobody wants to do that. So let's turn these back to be just 1 instead of 0.2. So they are interpreted as seconds, but that's only coincidental because the default clock is 60 beats per minute. These numbers are actually represented as beats, whatever the clock happens to be running at, when, you know, whatever clock this routine is played on. So let's create a tempo clock. So .new, we can almost always skip .new. And can I have a favorite tempo from the audience? 186. 186. So tempo clock expects its tempo argument to be given in, it doesn't, does it even say? No, I don't know if this is, aha, okay, there it is, yes. This tempo value is interpreted as beats per second. And we human musicians don't really think in terms of beats per second. We think in terms of beats per minute. But that's very easy because you can just divide whatever your beats per minute value you're envisioning is by 60, and that converts it to beats per second. So very important to remember this, otherwise your tempos are going to be extremely fast. 186 beats per second. Yeah, try conducting that. One thing I often like to do with tempo clocks is to append the permanent message and use this underscore syntax to set the permanent flag to be true. What this means is when you create this clock and press command period or do some sort of hard stop, the clock will survive. And this is nice because if it's not permanent and you press command period, the clock disappears, and then you'll have to go back to wherever your code is where you've created the clock and create it again and that sort of thing. So if you know you're going to be pressing command period a lot, it's probably good to make the clock permanent. So we can query a couple of things. We can say, what's your tempo? And it says, well, 3.1. And we say, OK, sure, fine. But what is that in beats per minute? There you go, 186. Right? So again, beats per second. We can also say, what is your current beat? And there it is. It's beat 109 point bunch of numbers. And we can kind of just press this a bunch, or even hold shift return to kind of see those beats being counted, right? 186 beats per minute. We can also, there's a couple of other convenient methods. If you want to know the duration of one beat, you can get that value. This is a value in seconds. This is useful if you're trying to scale some parameter in your SynthDef by, you know, the duration of one beat. And we can say next bar. This is going to give us a beat which has not yet happened, but which is the next beat to occur. And you'll notice these are multiples of 4. That's because t.beats per bar is by default 4. So it's not just counting beats, but it actually is sort of subgrouping these as here's a bar and here are the 4 beats and things like that. So see, is there anything else exciting? And the tempo clock help file has a bunch of good stuff here. So let's go back to our take this stuff here, and we've got our function playing 3 notes with a wait time of 1 beat between them. And all we have to do is, when we play the routine, I believe the first argument is just the clock to use. And you can confirm this. I don't think routine is in this drop-down menu, but it's one of its its parent class is stream. So routine is a type of stream. There's other types of streams we'll encounter, but a stream is just one of these processes that sort of knows where it is and can be suspended and resumed, I think. But anyway, this will now, you'll hear this will be quite a bit faster. These will be quarter notes at 186 beats per minute. And now it doesn't automatically get quantized to the nearest beat. This, like if we play this and then, play another one, it just sort of comes in whenever. Just as soon as we play it, it'll just get dropped onto the clock. It'll stay in sync. The phase will stay consistent, but if we want to actually quantize this, we need to provide some additional information. And for this, the second argument provides that quantization information for the routine. And so this is handled by the quant object, but there's a couple of different options for specifying quant. First thing I want to do is since the clock is 4 beats per bar, I think it'll make a little more sense if we create a looping structure which is actually 4 beats. So let's do, how about that? Right, so that'll sound like this. Okay, very good. By the way, command period, one of several things that command period does is it just stops any routines that are playing, which is very handy because if it only destroyed processes on the server, it would be useless here because the routine would just keep going and keep making more sense and there would be nothing we can do. And if we didn't give the routine a name, we wouldn't be able to stop it. And so it's nice to have command period stop the routines. Okay, so we're going to quantize this routine. And there's basically 3 components to a quant object. There's the quant value, the phase, and then the timing offset. And so quant is really the one we care about. This is the granularity. And so if we provide a quant value of 1, the start of the routine will synchronize with the next available beat. If it's 4, it'll synchronize with the next available multiple of 4 beats. In that case, I suppose the next downbeat. We could do 0.5. It would quantize with the next available 8th note, or half beat, however you want to think about it. And so that's quant. And then phase is an offset. We sort of use quant to specify the granularity, sort of the grid on which it'll get quantized. And then phase lets us push that forward or backwards in time. So +1 is 1 beat later, -1 is 1 beat prior. So if you want something to come in as a pickup note, on beat 4, you would probably specify a quant of 4 and then a phase of -1. And then it would just come in on the next beat 4. Timing offset is very rare that you need to use this. This is basically kind of an internal thing. For special cases where you have 2 playing routines and maybe the values of one depend on the values of the other. Like if you want, you have one process calculating frequencies and the other one is using those frequencies. If they're scheduled to happen at the same time, there's no mechanism to control the order of those thread executions. And so timing offset allows you to say, calculate this one, 100th of a second before the first. You'll almost never have to deal with timing offset. But it's just for sort of internal calculations and making sure that those internal calculations take place in the correct order by just making sure that something happens first or earlier than something else. So there's different ways you could specify quant as a quant object. So we'll say 4, 0, 0. So this is just a quant granularity of 4. And so if we play this, there might be a sort of sizable delay as we wait for the next downbeat to occur. And I think it helps if we actually schedule some things on the clock that show us the beats as they're happening. I guess we can maybe do this. It's hard to kind of run this and then try to time this. It's like I can't really evaluate 2 things at the same time. So let me use this opportunity to show you how to actually schedule things on a clock. There's 2 methods. There's sched and sched abs. So sched is a let's look at sched abs first. So we provide two things: an absolute beat value in the future on which to schedule something, and then a function to be evaluated. That's the actual code that will happen on that beat. And you might want to, you think, okay, we need a future beat. So let's see, beats, we're at 1414, so let's just try to, I don't know, maybe, we're not going to try to get, it's like we're doing some live coding here. We're trying to get the function done in time. So what I like to do here is t.next bar. We just say, wherever we are, just schedule this on the next bar. And then for the function, I'm going to make another function. So this is just going to say t.beats.postln, and then we're going to return the number 1. Okay, so we make this function, and then what we're going to do is run this sched abs call that says evaluate this post info function. And I will explain this returning 1 in just a moment. But so here, if we do this and then run this, now we have a recurring process. It's recurring because of this 1 at the end here. So it said, okay, I'm going to wait for the next bar, and then next bar, it evaluates this function, actually this function, and this function calls this function from over here, and it posts the current beats, and then whatever this function returns determines the number of beats before which the function is rescheduled. So by ending this function with a number, we can basically have a self-rescheduling process, which is nice. When we want to display beats, we just want to have this kind of visual aid so we can actually watch the clock as it's going. But we could do something like 4 and just kind of redefine this. And now it's only calling this post info function every 4 beats. We could do it every quarter of a beat if we wanted to. You want to be reasonable with your calls to post things, because you really can't ask too much. You don't want to be posting like thousands of things per second. It's going to make you sad. So now we're off phase here. So we can just change this function to be nil or just empty, and that has the result of unscheduling it, because this function no longer returns a number. And when something that isn't a number is returned, no rescheduling takes place. So, but we could just redefine this function and schedule it again, and then we've got these beats. So now going back to our routine, which we are quantizing on beat 4. So when we play this, it should synchronize with the next multiple of 4, which I guess we'll aim for 32. Yeah, there we go. Do this again, just so I'm going to aim for 60 here. Right, so it just drops right in on the next, beat multiple of whatever this is. Let's look at we'll have it start 1 beat later. So this, if I aim for 2016, it'll come in on 2017. And then there's a couple of different ways. Let's stop posting beats. So this is kind of the most verbose way to quantize a routine on a tempo clock. But there's a couple of alternatives. If you just specify a number, for example, if you don't care about phase or timing offset, you can just specify a number, and that will be interpreted as a quant value with only quant provide and nil for the others. You can specify an array of 2 values. Those will get dumped into quant and phase, or an array of 3 numbers, which becomes a full quant object. And if you don't specify anything or specify nil, then no quantization takes place, and the routine will simply begin immediately on the clock that you assign. Okay. I think what I'd like to do now is pivot to the non-real-time use of routine, which makes it sort of extra applicable. But before I do, is there anything here with TempoClock? Oh, I said I was going to talk about t.sched in addition to sched abs, right? So sched abs is, as the name implies, an absolute time on which something is scheduled. It's this beat, this specific numerical beat. Sched.abs will schedule something to occur at a relative beat. So basically, you give it a delta time, some number of beats later after the evaluation takes place. So we can just say, like, just do 4 beats from now. Let's go ahead and show our beats here. Let's do 8 beats from now. And actually, I don't want to do this one. This one's already scheduled. I want to go back here. And what do I want to do, actually? Okay, I am going to... Okay, I'll just make a simple sound here. Yes, and we're going to return nil just to be safe, because I don't want this to be rescheduled. So if we say t.sched 8, then this function will be evaluated 8 beats later. 4, 5, 6. Yeah, there you go. And nil means it won't be rescheduled, but if we were to do something like this, I'm going to have to hit command period here because it's going to start rescheduling, and I think I'm just going to have to command period. But 8 beats later, we run this function, which returns a number, and so it gets rescheduled. And because I didn't actually put this into an environment variable that I could redefine, I just have to kind of hit command period here. So that was, but really, I'm just trying to show sched and sched.abs. So does anyone have any questions on routines? Is there something I went over too quickly, or have I raised a question? No? You're all good? Okay. And the chapter, reading the chapter should also help kind of fill in any gaps that I might have skipped over. So that's playing a routine. But a routine is really just a type of stream, and a stream is a sort of performance of some sort of sequence. And we don't have to call play on it. We can actually call next on a routine. And the behavior is a little bit different here. So let's just go here, make this function, and also create a routine, but we will not play it. Right? So here's our function, here's our routine, and what we can do is call next on the routine. And what happens is the routine will begin evaluating, and it will stop whenever it encounters a weight or a yield. And technically, it will actually return the receiver of the weight or yield message. So here, when we play next, we will hear middle C, and then we'll see the value 1 posted in the post window. Okay? And this routine, a routine is a state-aware function, so it knows where it is. It's kind of hovering right here. It has the reason yield is the name of the method, alternative to wait, is because the routine yields control back to the parent thread, from which the routine is being called. So now we have control again, and when we run next again, the routine advances until it gets to the next yield or wait. So we can just kind of manually step through a routine. And so in this case, the actual number, or not even number, the receiver of the wait message is completely arbitrary here. It could be anything. It could be, I think it could be nil even. Right. Do this, sorry. Oh, no, maybe it has to be yield. Oh, this is the first time I've encountered a situation where weight and yield are not fully interchangeable. Yeah, interesting. Okay, but as I was saying, when we are nexting through a routine, and the stuff we care about is the stuff that happens between yields, then the thing that we actually yield doesn't really matter, because we're not doing this rhythmically on a clock. We're just kind of saying, give me the next thing. Just continue until you have to stop. Continue. So yeah, these are kind of meaningless here. But there are situations where it's actually the yielded values that we care about. Like this is an example where we're actually playing some sound. And so, you know, the yield doesn't matter, but it's just the sound in between that we actually care about. So another use of routines is to create some sort of data generating process, which is, you know, which can sort of branch and use randomness and conditional logic. So let's build like a we'll build like a function that generates MIDI note numbers kind of algorithmically. Like maybe we want to start at 50, and then we want to say, so we'll say num.yield, right? So the first thing we do is we yield the value, and then we're going to say num equals num plus somewhere between 2 and 5 semitones. And then, you know, this will just go up forever, right? But it's working, right? Maybe if we're doing MIDI note numbers, we need to have some mechanism to have it not just spin off into infinity. So does anyone have any suggestions? And what might we do here to modify this routine to make it more usable as a note number generator?
Set a trigger to break out of the loop?
Sure. Yeah, I was trying to think how to do that. I'm not sure there is a mechanism to actually break out of the loop. But we could use a different structure, like a while loop or something like that. So you've seen if. While is kind of similar. And this is, let's check the syntax structure here. Yeah, so while function, something to test, and then something to do. So we could say while num is less than or equal to 108, which is the highest C on a keyboard, we will yield and increment. It seems like it should work, right? Yeah, and there we go. So when we get to the end of a routine and we say, give me your next thing, it just returns nil because there's nothing to be returned. So yeah, that could work. And so now let's reset that. Right? We can always reset. And then next again, reset at any time, and we're back to 50. Another thing we could do is just go back to our original idea of saying loop and saying if, you know, at the end of here, if some threshold is reached, reset to 50 or do something else. It's completely up to you. You write the program however you want. But so let's go with this. And let me give this a more meaningful name. Notes function. And our notes routine is going to be a routine from notes function. Okay, so there we have that. And now we can say notes.next and notes.reset. Okay. And now let's grab another routine. Let's grab this one again. And what we'll do here is just kind of, I think I'm going to be kind of making this up as I go here, but we'll call this synths func. And we're going to say, give me the next note, convert it to CPS, and play a synth. And then we'll yield. But we know we're going to be getting nil at some point. And I'm not really sure what happens if we say nil.midi CPS. It doesn't like it. Right? So what we should do is we should say if. Well, actually, here's what we're going to do. For each loop, we're going to say the note will be notes.next. Just first, let's grab the next one from the queue, from the stream, and then we say if note.notNil. You can also do is not equal to nil. Right? That's fine too. But not nil is a right? 1.notNil, that's true. Nil.notNil, that's false. Nil is nil. So if node is not nil, then go ahead and do the thing. And then, regardless, we'll yield or wait for 1 second if played, or this will be our pause if nexting through. So let's just make sure we've done this correctly. Right, so we have our function, which is our number generator. We've created a routine from that function, which we can then next through. And here's what I forgot. We should not be calling notes next a second time, because just that call is actually going to pull the first note, store it in note, but then actually use the next one in the queue. So whenever you want to be pulling a value and using it multiple times, it's good to make a variable and just pull it once, use it throughout your routine, and then loop if you need to. So note here. Okay, and then we have our synths function. So then we could say, I guess, synths equals r synths func. Okay, so now we should be able to say synths.next. And before we do it, let's just walk through. So we're going to be saying, okay, we're entering a loop. We're going to grab the next note from notes, check to make sure it's not nil, and if it's not, play a synth, and then yield control back. And then that's the end of the loop, so we'll do it again and again. And then we're done. Cool. Let's reset, and we'll play. And so this should be a 1 second wait time, because we're not specifying a clock, so it's going to fall back on the default tempo clock, and 1.yield. And I'm just, I'm being cautious here, so let me save, just make sure I don't lose all this code. Better safe than sorry. Looks like a good time to save, right? Whenever you're about to play a routine with a loop, always save your code. What is today, the 3rd of October? I think that's right. I'll change that later if I need to. Okay. And did I forget to reset you? Is that what happened? What is it? Oh. Something fishy is happening here. I really should be, we should do this. Post ln and make this faster. Oh, okay, and then we should probably stop that. Right. What I think happened was that I had played the routine. I'm not really sure what happened with that lilting half beat there. I think I basically, it was at the end, and then I had played it and then defined it while it was still in a playing state, and I'm going to have to watch the tape back to figure out exactly what happened. But all I did was hit command period and just run this again, and then we're good. And so again we can play this on our permanent tempo clock, which is still counting beats back there, and it's going to do, I guess, 5 tuplets, right? A fifth of a beat at 186 beats per minute. Yeah. And I'm trying to think of the best way to just make this finite. I guess we can say while. Here's what we can do. Maybe we'll redefine this with say var. Take these things here, right? And then we'll just do a while loop again. While note not nil. Do this business. Let's see. Don't need that. Okay, so we've got our notes function, which is just going to be making notes and eventually spitting out nil. And so here in our synth function, we're going to say grab the next note. Well, it's not nil. Do this, and then we're going to have to get the next. I think we have to. Okay, we'll get this here. I think we need to also do this. Get the next note. Well, it's not. Enter this while loop. Play, yield, get the next note. Well, I think that should work. Yeah. Okay. Phew. I think that's all I really wanted to cover today. There's just kind of getting comfortable with routine, the concept of streams, playing on clocks, quantizing, and this kind of dual purpose of routine as something which can actually sequence sound, and using wait yield times as beat durations to pause between non-wait yield calls, and then the sort of non-real-time data generator kind of thing where you can have it spit out durations or note numbers or any other kind of control data you might need that you want to define algorithmically that you can't really do with a normal function because the function will just kind of do everything all at once. But the routine allows you to create these sort of substructures, iteration, nested iteration loops as a way of just defining the specific data you want to get out. And I do want to also say that once we get into the pattern library, which we will do next week and probably the week after that, you'll find that the patterns are a lot more convenient for this sort of thing because there are specific pattern objects which are kind of predefined to produce a particular type of sequence, like something random or something arithmetic or multiplicatively geometric or something like that. And those are kind of little pre-built objects that are going to work correctly, and you don't have to kind of roll your own with these routines. They're also a lot more convenient for, I think, a lot more convenient for making sound, in that a lot of that functionality is built in where you can create a pattern structure which is spitting out pattern-generated numbers for a bunch of SynthDef parameters and automatically creating synths with timing that you provide. That being said, even though I use patterns a lot, I still do find myself using routines and tempo clocks for a variety of things. They are useful. And that's what this week's homework assignment will focus on. You'll be basically making musical sequences, data sequences, and like sort of drum loops and stuff like that. Just kind of making sure that everyone's on good footing with routines and with tempo clocks. Are there any questions? Yes.
So I have two. One, is there any way to reset a tempo clock back to 0?
I have never found. I don't think it's possible to reset a tempo clock back to 0, short of actually just stopping it and creating a new one. But I have never found a need to reset tempo clock to 0 because you can always just say schedule on the next beat or on the next bar or something. Yeah, right. It's
just that concept of something afloat that's like always incrementing.
Yeah, I know. I have often forgotten. I look and it's like, oh my God, it's like 20,000 beats have gone by or something. It's you think of tempo clock as a kind of grid that just extends forever. And so you never really need to rewind a tempo clock because you always have that grid available. And as long as you're consistent with how you're quantizing different things, then you never really need beat 0 ever again.
And then the other question is there any way to, like the same way that we can access the default server with S, is there a way to access the default tempo clock?
Yes, TempoClock.defaults. That's, it doesn't, if you say beats, this one has been on for a long time and it's just counting seconds, right?
The number of seconds.
Number of seconds that have passed since I guess SuperCollider was opened or something. Yeah. So yeah, and you could store TempoClock.default in T if you really wanted to, right? No, but yeah, this is how you access the default clock.
Cool. Thank you.
Yeah. Any other questions? Yes.
Maybe we already covered this but can we change the speed of tempo clock on the fly?
You can, yes. So let's take a look at, you can change the tempo clock, the tempo on the fly. So here's this one going at 186. And let's just grab this stuff again, because this is kind of useful for seeing it in action. So we create our beat poster, and then we'll schedule it, and off it goes, counting beats at 186 beats per minute. You can, I think, just say t dot, there's like a 20% chance this won't work. Let's go down to 80 beats per minute. Okay, no problem. So you can do this. And a good future homework question, which I'm just now thinking of, is to use a routine to schedule a gradual tempo change by repeatedly calling this tempo thing. You know, because you can't really do a continuous tempo change on a discrete clock like this. You basically have to, you know, every beat or half beat, you have to sort of slow it down incrementally. And, but yeah, you can. There are some things like I know you can't do. Like if I wanted to say t.beats per bar, make that 3 instead of 4, you have to actually do that within a sked or skedabs command. Yeah, you can't just dynamically say beats per bar 3. It's sort of like the same reason you can't change the attack time of an envelope after it's already started, right? It sort of checks that at the beginning, and it needs to know. Basically, you need to have this happen on a specific bar. But I think this is pretty simple. So if we just say just on the next bar, set beats per bar to be 3 and return nil to not reschedule, then it has no problem with that. And now if we check beats per bar, it's 3. And so now basically we've done a time signature change for. I think that's a pretty reasonable way to describe it. Where now, you know, it's going to be, yeah, grouping beats in 3, and when you say next bar, it's going to be, you know, I need next bar. Oh, yeah, 5, 8. I got confused for a second. 11, right? So yes, to answer your question, you can change tempo on the fly, just dynamically. Okay, I've written the homework assignment. I just haven't uploaded it yet, but I'm going to do that right now. It'll be due in a week. Hope you have fun with it. Stick around if you have questions, and we'll start talking about streams, patterns, and events next week.